This video will describe nuclear chemistry. When a nucleus breaks down into a more stable nucleus, this is called radioactivity. Certain combinations of neutrons plus protons will yield unstable nuclei, and certain isotopes are more stable. For instance, carbon-14 is an unstable nuclei, and this is the one that's used for carbon dating. Whereas the nucleus that is in most of the carbon-based molecules in our bodies are usually carbon-12. This is the most abundant isotope. In other words, it's the more common isotope of carbon. It does not break down, so it does not undergo radioactive decay, which is another word for saying radioactivity. The products of radioactive decay are what we call radiation. The three most common types of radiation are alpha decay, beta decay, and gamma radiation. Alpha decay is a helium nucleus. That means that its mass number is 4, its atomic number is 2, so it has 2 protons and 2 neutrons, which is basically the same as a helium plus 2 atom, or a helium nucleus. Beta decay is 1 electron. Gamma radiation, gamma is the highest wavelengths of light, are the most energetic wavelengths of light. So gamma radiation is actually light waves. They are the most energetic wavelengths because they are a range of wavelengths of light. So if we're looking at our 3 types of radiation, the most common 3 types, an alpha particle, or a helium nuclei, that can be stopped by a sheet of paper or clothes. This is a heavier particle, and since it's a heavier particle than the other types of radiation, a simple sheet of paper, latex gloves, those types of things, it's very easy to block alpha particles, and so they are probably one of the least dangerous forms of radiation out there. Now, a beta particle, or an electron, that has to be stopped by something denser than paper. So it is stopped by aluminum foil. Oftentimes you'll see plexiglass used to stop beta particles. A thin piece of plexiglass, it doesn't have to be a super thick piece. You know, your normal sized sheet of plexiglass will do the trick, and that will stop a beta particle from getting to your DNA. Now, gamma radiation is very, very, very energetic light. Gamma radiation is so energetic that it can cross through many, many things. Visible light can go through a pane of glass, but infrared light can't. But gamma radiation needs lead, and thick lead. Lead is one of the most dense elements out there. It needs thick lead or thick concrete, something very, very dense, to block gamma radiation. Gamma knives are one of those things that was commonly used to treat cancer. Well, not super commonly used. That's because it is so absolutely energetic. So if we're looking at these types of radiation. Radiation is dangerous because it's what we call ionizing. UV light is also ionizing, not quite as energetic as these types of radiation, and it's not created by the nucleus of atoms. But that's also why we hear that UV light causes cancer. But when this type of radiation hits you, so the alpha particle, the beta particle, or gamma, and that's the Greek letter gamma, when they hit you and they hit your DNA, they will pop off an electron. That causes free radicals to form in your body. And since oxidation is loss, that also causes your DNA or proteins or whatever biomolecule that it runs into to be oxidized. This is one of the reasons that we take a lot of antioxidants. We will get some types of radiation naturally. Granite has minerals in it with radioactive elements, and many other types of stone have some radioactive elements in them. It is natural, but we don't want to expose ourselves to too much of this ionizing radiation, because when it pops an electron off, now your DNA, and I'm going to draw a single dot here to represent an unpaired electron. Now, it can see other things that might have unpaired electrons. For instance, it might find a chlorine free radical. Chlorine tends to make a lot of free radicals, and then you will get something funky forming. Or your DNA free radicals can react with oxygen, which we know is around a lot of places, and that will form a oxidized DNA. And all of these things are bad because they impede DNA's ability to function. And that can cause things like cancer and radiation poisoning. It just depends on how much dosage of radiation you get as to how many of these molecules, and it doesn't just happen to DNA, it can happen to proteins, it can happen to a lot of other really important biological molecules in the body. And once their ability to function is impeded to a certain extent, we end up with death. So there are escalating ways that DNA or that radiation can hurt you.